we fine-tuned the YOLOv9 model on a custom aerial dataset and achieved an impressive MAP50 score of 0.716. Continue watching this video to know how. Hey there, welcome to Learn OpenCV. In this video, we understand the experiments involved in fine-tuning a model, see how the fine-tuned YOLOv9 model fares and its inference results. We will be using the SkyFusion aerial object detection dataset for this task. It has 3 labels: aircraft, ship and vehicle, with around 2100 samples in the training set, 450 samples in the validation set and 450 samples in the testing set. To check the code for the experiments, open the Learn OpenCV blog post link from the description, click on the download code banner, fill in your details and hit enter. You'll receive the starter code link on your email. In our first experiment, we trained the YOLOv9 compact model for 100 epochs and get the initial MAP50 score of 0.712. This is our baseline performance. But what about YOLOv8? If we run the same experiment on the YOLOv8 medium model, we achieve 0.689 MAP50 score, which is a 3.2% decrease from the baseline. Clearly, YOLOv9 is the way to go. Now that our baseline is established, we'll try to beat it. In our first experiment, we freeze just the backbone. YOLOv9 has been trained on tremendous amounts of data. The backbone is already good at extracting the features, so it doesn't make sense to train it again. In the model architecture, the first 10 layers represent the GELAN backbone. We're gonna freeze this. Freezing the backbone and then fine-tuning the model, we get 0.629 MAP50 value, which is lower than our baseline. Our second experiment is to continue freezing the backbone but also lower the learning rate. The model's default learning rate is 0.01. Freezing the backbone and decreasing the learning rate to 0.001, we achieve an MAP50 value 0.609, which is even lower than our first experiment. This will simply not do. In our third experiment, we continue freezing the backbone but increase the input image size to 1024. In this experiment, we get the MAP50 value as 0.716. Since our dataset is made up of small objects, increasing the model's input image size is definitely going to help. Now let's take a look at the inference results. So, these are the kinds of experiments we need to run when we fine-tune a model. If you like this video, why don't you check out other videos in the YOLO Masterclass playlist? Do comment on what you would like to see next and don't forget to subscribe. Thanks for watching. Until next time.